Okay, real quick, I just want to talk about absolute value problems because that's something we're going to look at in section 1.4. So as you guys remember, when we're finding the absolute value of a number like 9, we want to look at how far away from 0 that number is. So for 9 is 9 places away from 0, 9 away from 0. So the absolute value of 9 is 9. The absolute value of -9 would also be 9, because -9 is also 9 away from 0. So what happens when I have a variable in my absolute value bars? So the absolute value of a number is 9. Well, I know that there are two possibilities. This number could be +9 or it could be -9, because the absolute value of +9 is 9, but the absolute value of -9 is also 9. So in this instance, if I were to solve for x would be equal to +9, but x would also be equal to -9. So I have two answers. And one way we sometimes write this is x is equal to plus or minus 9. That looks bad. Let me rewrite that. X equal to plus or minus 9. So either way is an okay way to write this, or you could write it like this: x equal to 9, comma, -9. All three of those are valid ways to write this. So another example, let's say the absolute value of 3 times x is equal to 18. Well, I know that the absolute value of a number can be either positive or negative, so I need to solve for the absolute value of this number being positive 18, but also negative 18. So I'm going to set this up twice. So solving for 3 times x equal to 18, I'm going to do the opposite of multiplying by 3. I'm going to divide by 3 on both sides. 18 divided by 3 gets me 6. So one solution to this is 6. Now I'll do the same thing over here. Divide by 3 to cancel that 3 being multiplied. And I get that x is equal to -6. So here I have two answers, x equal to 6 and x equal to -6. If I plug in 6 here, 6 times 3 is 18. The absolute value of 18 is 18. If I plug in this -6, 3 times -6 is equal to 18. 3 times -6 is -18. The absolute value of -18 is 18. So I know that x is equal to 6 and -6.